0 from here. -2, the second factor. +1, the third factor. It's 2, 4, 5. The degree is 5, which tells me the end behavior will be opposites. A positive x times a positive x times a positive x tells me it is a positive leading coefficient. So, odd positive leading coefficient will fall to the left and rise to the right. Odd and positive fall to the left, rise to the right. Now, at -2, it was to an even. So when it's to an even, when the factor is to an even power, it is tangent. It bounces. 0 is to an even. So when a factor is to an even, it bounces. This is an understood first power, so it's going to pass right through. Odd passes. All right, so that's how you would sketch a graph. Now, when I sketch a graph, do I know where these mins are? I have no idea. You are sketching. Your maxes and mins will not be perfect. The only ones that will be perfect is when the max, local max, occurs at an x-intercept. We can get the x-intercepts from these factors. That's where x-intercepts come from. Okay, so big idea. This is what you should have gotten. The first thing is the degree of the function. When we find the degree of the function, now, 2 ways to find the degree of the function. If it's in standard form, which none of these were, it is the monomial of highest degree. If it's in factored form, we're multiplying all those factors, so when we multiply like bases, we have to add the exponents. So once we find the degree, if it's even, the ends are going to do the same thing. They're either going to rise, rise, or fall, fall. If it's odd, those ends are doing the opposite. Now, that tells us about the end behavior of the function. That's where we start on the graph. Well, actually, it's the second thing we do. The first thing we do is plot all those x-intercepts. Then we do end behavior. And then, looking at those intercepts, we look at each one individually. Was that factor raised to an even power? Because if it was, it's tangent at that point, at that x-intercept. It bounces back at that x-intercept. But if that factor was raised to an odd power, it's going to pass through. Now, it passes through with inflection if that odd power is greater than 1, like the cubics. That's where it switches concavity, from concave up to concave down, or the reverse of that, concave down to concave up. Now, the leading coefficients, what do they tell us? They tell us which way this end behavior is going. So if our leading coefficient is positive and our degree is even, it's rise, rise. If our leading coefficient is negative and our degree is even, it is fall, fall. If our leading coefficient is positive and it is odd, then it falls to the left and rises to the right. But if our leading coefficient is negative and it's odd, then it rises to the left and falls to the right. Now, how do we get the y-intercept? Well, all we have to do is plug in 0 for x. If we plug in 0 for x, that's going to leave us with y equals something. Well, that's our y-intercept. So if we plug in 0 for x, it's our y-intercept. Now, if it's in standard form, it is just the constant. But if it's in factored form, we're going to have to do some multiplying. Now, how do we determine the x-intercepts of the graph? Well, in factored form, it's really easy. It's what values of x make that factor 0. Okay, so your homework is to finish up the packet, just a couple little problems, and we're going to talk about those tomorrow.